All right. So by popular vote or unpopular vote, I'm going to go ahead and work through an example of solving trig equations. So here's our problem: 3 tangent cubed x equals tangent x, and we're given the instructions to solve this. Oh, technical difficulties. There we go. We're asked to solve this. So first, when I look at this, I do like the fact that tangent is the only trig function in there. That's kind of nice. But that cube is really, really annoying, and so it really makes me think that I want to break it down somehow. Now, I know I could get rid of a cube by cube rooting, but if I were to cube root both sides, then I'd end up with, it would be nice on the left-hand side here, but on the right-hand side, it wouldn't be very nice. I'd have the cube root of tangent of x, which is just really bad. And so I'm wondering how I can break that cube down in a different way. And the thing that I like is I notice that tan is in the left-hand side and the right-hand side. And so while some people think we can just divide by tangent, I'm actually going to get everything on one side, because this is making me think that I could factor out something, because both the left and right, basically every term in this has tangent in it. So what I'm going to do is I'm going to go ahead and subtract tan x from both sides of this equation, which would leave me with 3 tangent cubed x minus tan x equals 0. And that's nice because it's equal to 0, and we've talked about this a lot and how that helps. And then when I look, I really have two terms now. You know, I have the 3 tangent cubed and my tangent x, and both of these terms have tangent in them. And so that means that I want to get rid of that somehow. I could actually undistribute it or factor it out. So I'm going to go ahead and do that, and I'm going to write that in purple so you can see what I did. And then what that would leave for me is 3 tangent, and if I pull one of the tangents out of that tangent cubed, I'd still have tangent squared x minus, and if I pull tangent out of tangent x here, I would end up with just 1. And this is going to be equal to 0. Which, like we've talked about, this is so nice because now I can set both these pieces equal to 0. You know, I have two terms here. I have or two pieces to this. I have one group there and I have one group here, and both of those could really be seen as being equal to 0. So maybe my colors coding is kind of nice here. Tangent x equals 0, or 3 tangent squared x minus 1 equals to 0. And now I still need to solve. Keep in mind, if we go back to our instructions, right up here, I am asked to solve this, which means I need to find the values that make it true, the values of the variable that make it true. I am being asked to find the values of x that make this true. So if I go down here to the purple one, I'm wondering, when is tangent of x equal to 0? And now I know this because I have my automatics memorized, but you guys might want to refer back to your automatic sheet or think about it. If I think about where we could be to make tangent x 0, I know that we could be here or here, which means I know that x can be 0 radians, or x could be pi radians. And not only that, I want to find all solutions. See how it says like solve? It's not just saying, you know, in some interval. So the thing is, I could be anywhere where I can get to this spot. So I could go all the way around if I wanted. And I could keep doing that. And so this is why we're adding 2 pi n, where n has to be an integer. And I could do the same thing down here, where n has to be an integer. Now, some people will notice that really both solutions here, if we go back for a second, both solutions are just pi apart, and so some people might choose to write this instead of the purple, they might write 0 plus pi n, because that would get me all of them. Or they might just write pi n, because, you know, the 0 is really unimportant. Whichever way you like, purple or orange, doesn't really matter. Okay? All right. So that solved this purple part of my equation that came from my algebra, but I still have this black. So if I come over here to the black, I really want to find tangent of x. I want to isolate, because I want to get x, right? I want to solve for x here. But that really means I have to isolate tangent of x first. One thing at a time, right? So if I add 1 to both sides, then I could get 3 tangent squared x equals 1, which is nice. And then I could get rid of that 3 by dividing by 3 on both sides. And so I would get tangent squared x equals 1/3. And then I don't like that square. So to get rid of a square, I can square root, and that'll work out nicely. And there I have to keep in mind that tangent x could be positive or negative. It's really important that we have that. Root of 1/3. Now I'm running out of room, so I'm going to go ahead and erase some of my earlier work, so we have more space for this. You know, you guys have already seen that enough, right? We're good there. All right. So, if we come back up to the top, I know that tangent of x could be, and I don't really like that root of 1/3. I don't really want to write that differently. So I notice that that's the root of 1 over the root of 3, which, that's ugly. I mean, that's really just 1 over the root of 3, but we don't like that because it's not rationalized. And so if I were to rationalize it, multiply by root 3 over root 3, we'd realize that really tangent of x is equal to the root of 3 over 3. Aha! That's an automatic. I know that one. And so you could look at your automatic sheet, or you should at least look familiar. And so I know that tangent of x is the root of 3 over 3 when x is equal to pi over 6. And again, if I draw my little circle, I know that's going to happen here. It's also going to happen here. So I could do, you know, the two solutions and add my 2 pi n, or I could realize, like we did down here in orange, that these are really just pi apart. And so I'm going to use that and just say plus pi n, where n is an element of the integers. And then, you know, I have to do the same thing with tangent of x equals the negative root of 3 over 3. You know, I just took this this down here, and I don't really want to rationalize it again. I mean, I already did that work, so why repeat, right? And we can get x equals, and I have to know where this one is. And really, that's going to be either here or here. And so I realize that that's at 5 pi over 6 plus pi, and again, because I realize that, you know, they're half rotation apart. And so if I look at my answers, I have these values of x, these angles, when plugged into our original equation, would work. These angles, when plugged into our original equation, would work. And if I come down here, all of these angles, and I could circle the orange. I'm just circling this one instead. When plugged in my equation work. So these are all the solutions to that original equation that we had. Hope this helps. Have a great weekend.